Hey guys, how's everybody doing? Just wanted to take a little bit of time to go over some of the important things from the notes for Work and Power. Day 1, you should only be going over the slides that are talking about the vocabularies work and power. So I'm not going to go over everything on the slides, but just highlighting a few things. Number 1, let's just talk about the word work very briefly. Work is equal to force times displacement. The most important thing that I need you to remember from this, or hopefully you caught, they were written in red letters, was that we needed to make sure that the direction of the displacement experienced by the object is in the same direction as the force applied to the object. If the force and the direction of the displacement are not the same, then we say in physics that zero work was done. So for example, if I have a person and they are holding a box, and let's say that this person paces back and forth across the room. In physics, if I were to ask you how much work is being done on the box, the answer to that question would be 0 joules of work. Now, this is something that I would typically demonstrate in the classroom. I'd grab my little basket of markers, carry it around the room, and ask this question. You need to understand that if the question is asking about the work done on the box, then we need to take into consideration what direction is the force that's acting on the box. Well, right now, the force acting on the box is upward, because it is the force of me holding the box so that it doesn't fall to the ground. If we're asking for the direction of the box's displacement, well, any displacement that it experiences is horizontally. So the simple fact that the displacement and the force are not in the same direction, that's what causes the amount of work acting on the box to be 0. You also need to be careful for future questions. Let's say that I didn't have me pacing. What if I just walked from the left to the right? My displacement here is to the right, my force is up, my work is 0. If we were to have a situation where, let's say, this box is on the floor, and then I apply a force to lift it up here, then yes, I would have done work on the box. The amount of work that I did would depend on what is the value of that force upward and what is the value of this displacement upward, and those two things would give me however many joules of work was performed on the box. If I'm telling you that we take a box and we move it from the ground up and then we bring it back down to the ground, then in this case, my amount of work done would once again be 0, because if I'm asking you overall, my displacement, remember, is beginning location to ending location. So if it started on the floor and came back to the floor, then my overall total work done would be 0 because my displacement is 0. Okay, so these are some of the little things that I would normally have elaborated in class that's not on the PowerPoint. When we're talking about power is pretty straightforward. It is simply the amount of work that someone performs in however much time. So your responsibility here is to make sure that you are plugging the variables into the proper location. I typically warn students that when we're talking about the units for these variables, work is measured in joules, time is measured in seconds, power is measured in watts. Be careful, because we have a W for work and then we have a W for watts, and they are not the same W, okay? So when you're reading through the problem, when you are doing your listing of your givens, be very cautious about how you are identifying your variables. Just to review, the instructions are that you're supposed to list your givens by telling me the value that you are provided and then you are supposed to tell me which variable that value represents. So when we list our givens in this manner, then this W for work on my list of givens represents this W for work in my formula. Okay. The other thing that I wanted to remind you of is if you are being asked to solve for power and you don't know what the work is, then you can simply go and find that work value, provided that you have the force and displacement. This is going to happen quite often for you guys. So your options here are to either say that, let me just get this out of the way so I can write them side by side. We can either say that work is equal to force times distance, come over here, plug in our numbers, find our work, then take that work value and simply plug that in here, and then do power is work divided by time. Or for those of you who are more advanced in your algebra and you feel comfortable, you could also just rewrite your formula so that you do force times distance as your numerator and then go from there, okay? If we are talking about what formulas I would be putting on the board as your official formulas to use, the formulas on the screen here in black, these are the ones that you will be provided when it's time for your test. And this formula over here is just for those who feel like they're comfortable in merging the formulas so that it's a one-step problem rather than two. You do whatever is comfortable for you, okay? All right, that was it. Just wanted to go over a couple of things that I normally elaborate on that are not necessarily written out for you in the PowerPoint that I have posted on